Okay, so let's try to go through this question together. This figure is showing a seesaw balanced with a force as indicated. So as you are able to see, this is a seesaw. This is coming from principles of moment. Yeah, so we are just going to see how we can just come up with the answers. So we are saying the figure B4.1, okay, the 200 force is 2 meters from the pivot. The 100, in other words, this information here is just interpreting what is on the seesaw here. So let's go direct to the questions. So A states the principles of moment. How do you state the principles of moment? We stated that for a body to be in equilibrium, the clockwise moment must be equal to the anti-clockwise moment about the pivot. So for a body to be in equilibrium, the clockwise moment must be equal to the anti-clockwise moment. That is how you define the principles of moment. As simple as that. Let's go to B. Calculate the distance y. So how do you calculate the distance y here? This is the distance that they want you to calculate from here to there. So what are we going to do? We're going to use the principle of moment formula. So this is the formula. So we're going to say F1 D1 equals, okay, so the F1 and D1 is for this side. We have got the force and the distance. So let's come to this side. So here we have got the F1, F2, D2. So let's write F2, D2 plus, we're not going to end there because we have more distance. This is D3 from the pivot to here, that is D3, and then F3. So we're going to include them as well. So we're going to say F3 D3. So we're going to start picking the what we have there. On F1 we have 200. So we're going to say 200 newtons multiplied by the distance, which is 2, because F2 we have 150 multiplied by the distance, which is x, plus F3 we have 110, okay, multiplied by the distance, which is 2 meters, okay. So when we multiply that, we are having 400 equals 150x, okay. When I multiply that, we are having plus 220, okay. Hope I'm not mistaken. So when we reach here, guys, you're going to take this one on the other side there, okay. So you're going to have 400 minus 220 equals 150x. So when you subtract that, you're going to remain with 180. Okay, yeah, 180 equals 150x. So if you want to find the value of x, you divide 150 throughout. You divide 150 throughout. So 150 and 150 cancels, and then this is 0, and that one is going to cancel each other. Okay, so 15 into 18, so you're going to have 1.2 meters. That is how you find the value of x. Okay, let's move on to the next one. So the next one is saying C, find the force x acting upwards. Okay, find the force x acting upwards at the pivot. So they want you to find the force that is acting upwards on the pivot. We have got these forces that are acting downwards, but we also have another force that is acting upward. What is that force? So we're going to use what we call the Newton's third law of motion. So third law of motion. What does this state? Okay, to every action there's an equal and opposite reaction. Okay, so if we have this is a pivot. If we have forces acting downward there, and then we have another one here, so this one here is 200, the other one there is 150, the other one there is 110. So how is this going to help us, ladies and gentlemen? So when these forces are acting downwards, how much is the force that is acting downwards? We're going to say 200 plus 150 plus 110. Okay. So when you add them, you're going to have okay, this is 350 plus 110. 0 is 6, this is 4. Okay, so this is the force that is acting downwards. And according to Newton's third law of motion, the force that is acting downwards is producing an equal force on the other opposite side. So the force that is acting downward is producing an equal effect on the opposite direction, on the opposite side. So this force is equal to the force that is acting upward. Okay, it's equal to the force that is acting upward. So the force that is acting upwards there is 460, if my calculations were correct. But what you need to do is just to add this, and then you are going to have the opposite force. Okay, so that's that. I think we're done. Do you have any? No. So that's how we come up with the answers. Thank you very much.